It is Monday, January 19th, 2026. And I want to start today by asking you to do a little mental time travel with me. I want you to picture plumbing. When I say that word, what's the immediate image that pops into your head?
For most people, I bet it's a very specific, almost, gritty scene.
Right. It's the smell of burning flux, that acrid smoke that kind of hits the back of your throat.
Mm.
It's the hiss of a blue propane flame.
Mm-hmm.
The guy in heavy overalls, maybe kneeling in a puddle under a sink, sweating copper pipes together. It feels industrial,
Yeah.
archaic almost.
Yeah, like blacksmithing or welding. It's definitely a 20th century image, maybe even late 19th century.
But looking at the stack of industry reports and analysis on my desk today, and these cover the state of the trade right now in 2026, and look ahead to 2030, that whole image is rapidly becoming a historical reenactment.
It really is. We are seeing a shift to smart metals, to surgical grade repair tech that honestly looks more like medical science than construction.
And a massive global move away from fire.
The trade is undergoing a fundamental identity crisis. It's moving from an art form, flame, solder, intuition, to a high-tech assembly discipline.
So that is our mission for this deep dive. We are exploring the future of the pipe. We're going to unpack why the walls of your house are becoming high-tech and why, if you are a homeowner or a DIYer, the old rules of repair, they just don't apply anymore.
And it's not just about the tools, though the tools are fascinating. It's about the health of the water you drink, the integrity of your home, and really the economic reality of maintaining a building in the late 2020s.
Okay, let's start with the most visible change. The extinction of the blowtorch, as one article put it. For decades, if you wanted to join copper pipe, you soldered it. It was the gold standard. So before we talk about what's replacing it, maybe walk us through the status quo. Why was soldering king for so long?
Well, traditional soldering is a chemical bond, and it's actually a pretty complex process. You have to mechanically clean the copper pipe until it shines.
Right, with the sandpaper.
Exactly. Then you apply flux, which is that acidic paste that eats away oxides and protects the metal while you're heating it. Then you take a torch and heat the joint to somewhere between 400 and 600 degrees Fahrenheit.
Which is hot enough to burn down a house if you aren't careful.
That's the risk. Once the copper is hot enough, you touch the solder wire to the joint, and then physics capillary action sucks the molten metal into the gap. It cools, and you have a watertight seal. When it's done perfectly, it's incredibly strong.
When done perfectly, that's the catch, isn't it?
That is the massive drawback. It relies entirely on human skill. If you don't heat it enough, the solder won't flow. You get a leak. If you overheat it, you burn the flux, the solder won't stick, and
You get a leak.
Get a leak. Plus, it creates smoke, fumes, and it requires a hot work permit in most commercial buildings now.
Enter the disruptor, the technology that is basically taken over by 2026. Press Connect, or Press Fit technology. The data shows something like 1 million press connections are installed every single day now.
Yeah, the dominance is nearly total in new commercial construction, and it's just sweeping through residential, too.
So describe the mechanics here. I've seen the tool. It looks like a sci-fi power drill with this heavy metal jaw. But what is actually happening inside that fitting? Because there's no glue and there's no melting metal.
That's the key difference. Instead of a chemical bond using heat, it's a mechanical bond using force. So inside the copper fitting, there's a specialized bead or a groove, and sitting inside that groove is an O-ring.
An O-ring, so a rubber washer.
Essentially, yes. It's usually made of EPDM rubber, that's ethylene propylene DN monomer. It's a synthetic rubber known for its high heat resistance and longevity.
Okay, I have to play devil's advocate here immediately, because if I'm a homeowner or a traditionalist plumber, I hear rubber O-ring and I get nervous. Copper lasts 50, 70, maybe 100 years. Rubber. It dries out, it cracks. My garden hose washers don't last 5 years. Are we sacrificing longevity for convenience here?
That is the #1 criticism, and it's a valid concern to raise. But the engineering suggests otherwise. These aren't garden hose washers exposed to the sun, The O-ring is housed inside the metal fitting.
Okay, so it's protected.
It's protected from UV light. It's protected from physical damage, and when the tool clamps down, it delivers thousands of pounds of force.
It actually crimps the metal permanently.
Right. It deforms the copper fitting and the pipe itself into a hexagonal or octagonal shape, and that compresses that O-ring against the pipe wall. It creates a stored energy seal. The metal wants to spring back, but it can't, so it stays under tension. The manufacturers are rating these for 50 years plus, so they're matching the lifespan of the copper itself.
So the metal holds the structure, but the rubber is what actually stops the water.
Exactly, it's a cold joint.
Let's look at the efficiency stats then, because this is where the industry reports really jumped out at me. Press fittings are listed as 50 to 70% faster than soldering. 70% is a massive number.
It is. It's the difference between doing a job in 3 days versus doing it in 1 day.
But why is that speed so critical? Is it just about plumbers wanting to get to lunch earlier, or is there something bigger driving this?
It's macroeconomic. We have to look at the labor market. For the last 10 years, we've had a severe labor shortage in the skilled trades. We have far more master plumbers retiring than we have apprentices entering the field.
The famous skills gap.
Precisely. So, if you run a plumbing company, you can't find enough people who can perfectly sweat a solder joint in a tight corner upside down. I mean, that takes years of practice to master.
But press fit is different.
It lowers the barrier to entry significantly.
Because the tool does all the work.
You can train an apprentice to use a press tool safely and correctly in just a few hours. The tool prevents you from under-crimping. It cycles completely or it doesn't open, so it removes that human error variable. It allows a smaller, less experienced workforce to complete more infrastructure in less time.
It's technology filling the gap left by a shrinking workforce. And the safety angle seems huge, too. I mean, if I'm renovating an apartment building where people are living, I imagine the insurance liability of an open flame is just a nightmare.
Oh, insurance companies love Press Connect. Love it. No flame means no fire watch required. You can fix a pipe in a hospital, a school, a historical wooden building without risking burning the place down.
I saw another term in the notes, wet repair. What does that mean?
This is a huge practical advantage. If you solder, the pipe has to be bone dry. If there's even a tiny drop of water trickling through, it turns to steam when you apply the torch and it blows a pinhole in your solder joint. You simply cannot solder a wet pipe.
Which, if you have a leaky main shutoff valve, is a total disaster.
It's a nightmare. You have to wait for it to drain. You use bread to stop the flow, all these old tricks. With Press Connect, you don't care. You can press the fitting even if there is water actively in the line. That's a game changer for emergency repairs.
That explains why the blowtorch is extinct in new construction. It's faster, safer, easier to teach. But let's pivot to the material itself. Because while the joining method has gone high-tech, the material copper is getting squeezed by plastic.
You're talking about PEX, cross-linked polyethylene.
Right. You walk into any hardware store, and it's just a sea of red and blue plastic tubing. It's flexible, it's cheap, it doesn't corrode. If I'm building a house in 2026, why on earth would I pay the premium for copper? Is copper becoming a dinosaur?
If you look at the raw numbers, copper is definitely losing the cheap and fast battle to PEX in residential, but it's not dying. It's pivoting. It's kind of rebranding itself as the premium wellness material.
This is where the reports mention antimicrobial enhancements. It sounded almost like biohacking for your house. I assumed a pipe was just a tube, but apparently copper is active.
It is, in a very literal sense. We've known for centuries that copper kills bacteria. It's called the oligodynamic effect.
The oligodynamic effect. Okay, break that down for us. What's happening at the microscopic level?
Essentially, copper ions are released from the surface of the pipe. And these ions are toxic to bacteria, viruses, fungi. So when a microbe lands on the copper surface, the ions punch holes in its cell membrane and destroy the DNA inside. It's a contact kill mechanism.
So the pipe is actively sterilizing the water that's touching it.
It creates a hostile environment for pathogens. Plastic doesn't do that. In fact, plastic pipes have a microscopic texture that can sometimes harbor biofilm, that slimy layer where Legionella and other nasties can hide and multiply.
Legionella, that's the bacteria that causes Legionnaire's disease, a serious pneumonia.
Exactly. And in a post-pandemic world, building managers, hospitals, homeowners, we're all hyper-aware of air and water quality. So the industry is doubling down on this. We're seeing new manufacturing techniques that actually increase the surface area of the inner pipe wall to amplify this antimicrobial effect.
So the argument changes. If PEX is the budget-friendly option, copper becomes the health plus option.
Precisely. It's positioning itself as a luxury health product.
There's an economic irony here, though, isn't there? We just talked about how press fittings save labor costs.
Right.
So you use the money you saved on labor by using the fast press tool to pay for the more expensive copper material. It basically balances out.
That is exactly the pitch plumbing contractors are making. We can give you the premium healthy copper system for the same total price as the plastic system because we can install it in half the time.
It's a compelling argument. But we have to address the elephant in the room with copper: longevity. Specifically, pinhole leaks. One of the sources highlighted this as a major issue. This sounds like an absolute nightmare. A pipe deep inside a wall just dissolving.
It happens. It's often due to water, chemistry, hard water, high chloramines, or just turbulence wearing down the metal over 20 or 30 years. And you get these tiny needle-sized holes.
And traditionally, the solution was catastrophic.
The jackhammer solution.
Yeah. Right. You have a leak under the concrete slab of your living room. So you have to smash the floor, rip out the tile, cut the concrete, find the pipe, and replace it.
Yeah.
It costs thousands and just ruins your house for weeks.
It's invasive, it's destructive. But this is where the surgical side of 2026 plumbing comes in. The industry calls it CIPP, cured-in-place pipelining.
The analogy they used in the report was angioplasty for your home.
It's a perfect comparison. I mean, think about modern heart surgery. We don't cut the chest open to fix a blocked artery anymore if we can avoid it. We insert a stent through a tiny opening. CIPP is the exact same concept for your house.
How does it actually work? Because you can't just shove a loose plastic tube inside a pipe and expect it not to leak between the layers.
No, it has to be bonded. It's actually quite clever. They take a flexible textile liner, it's almost like a felt sock, and they saturate it with a specialized epoxy resin.
Okay, so a sticky, wet sock.
Then, using compressed air or water pressure, they invert it into the pipe.
Invert it?
Yeah, think of it like turning a sock inside out, but you're pushing it into the pipe as it turns. So the wet, sticky side that was on the inside of the sock ends up pressing against the wall of the old copper pipe.
Ah, I see. So the resin is forced directly against the old metal.
Exactly. It conforms perfectly to the shape of the pipe, filling in those pinhole leaks, covering cracks, smoothing over rough spots.
It's so block.
Yeah.
Grise.
Well, curing is the technical term. In the past, they used hot water or steam, which took hours. But the tech we're seeing in 2026 is using UV light.
UV light inside a pipe.
Yes. The resin is photoreactive. Once the liner is in place, they send down a light train. It's a string of high-intensity UV LEDs on a cable. They pull it through the pipe, and as the light hits the resin, it hardens instantly.
Instantly.
In minutes. It turns into a rock-hard structural plastic pipe inside the old copper shell. It's seamless. There are no joints to leak.
So you're essentially building a brand new pipe using the old one as a mold.
That's it. And you do it all from 2 access points, maybe a clean out in the yard, and a drain under the sink. No jackhammers, no dust, no ruined floors.
I assume this reduces the diameter of the pipe, though. Does that kill your water pressure?
That's the common question. And it does reduce the diameter slightly, maybe by a few millimeters. But here's the irony. The new epoxy surface is so much smoother than the old corroded copper that the flow rate often improves. There's less friction.
That is fascinating. It really changes the repair versus replace calculus.
Completely. It extends the life of the system by another 50 years. It started in city sewers, moved to commercial buildings, and now it's becoming viable for residential homes. It's the no-dig revolution.
It really feels like we are moving away from brute force smashing walls, welding metal, and toward these elegant, high-tech solutions. But I want to talk about the rules of the game, because none of this happens in a vacuum. The government is always a silent partner. What is the regulatory landscape looking like as we head toward 2030?
It's getting stricter. The big push is lead-free.
I thought we got rid of lead pipes decades ago.
We got rid of lead pipes. But for a long time, the solder used to join copper had lead in it. And even after that was banned, the brass used in fittings allowed for a tiny percentage of lead because it makes the metal easier to machine. The new regulations are driving that to effectively 0.
Which sounds good for health. Lead is bad, we know this, but does it change how the work actually gets done?
It actually makes the traditional methods harder. The new lead-free solder alloys, they're usually based on bismuth or tin or silicon, behave very differently under heat than the old lead tin mix.
Differently how?
They have different melting points. They don't flow as easily. A bismuth-based solder might become brittle if you cool it too fast. It just requires much more precision with the torch.
So the art of soldering is getting more technically difficult, just as fewer people are learning how to do it?
Exactly. You're asking a shrinking workforce to use a more difficult material. And this is actually another massive driver for Press Connect. A press tool doesn't care about the melting point of bismuth. It doesn't care about alloy composition. It just crimps.
It removes the variable.
It de-skills the installation to ensure compliance. It guarantees a lead-free connection without relying on the plumber's ability to manage complex thermal dynamics.
And then there's the environmental side. We touched on PEX being the cheap competitor, but plastic has a baggage problem that's getting heavier every year.
It does. Microplastics. As we become more aware of microplastic pollution in our blood and our water, the idea of having water sit in plastic pipes for decades is starting to raise questions.
Is there evidence that PEX sheds into the water?
The science is still evolving.
Yep.
Right now, PEX is considered safe and it's code compliant.
Yeah.
But we are seeing early research asking, what happens to the chemical stability of this plastic after 40 years of chlorinated water running through it? If regulations start targeting microplastic shedding, copper is going to see a massive resurgence.
Because copper is a natural element.
Copper is 100% natural and infinitely recyclable. If you tear a copper system out of a building, you scrap it, melt it down, and it becomes new pipe with zero loss of quality. PEX usually ends up in a landfill.
So let's gaze into the crystal ball. We're in 2026. If we look out to 2030, based on these reports, what's the verdict?
I think we are entering a hybrid era. The binary choice between old school and new school is gone.
So what does the hybrid plumber look like?
For new construction, it's mechanical. Press fittings will likely hit 80 or 90% market share. Flame soldering becomes a niche skill, used only for specific repairs where a tool can't fit, or for vintage restoration work.
And the pipes themselves get smarter.
Yes, we will see smart antimicrobial copper systems in high-end and health-critical buildings. And for repairs, the days of digging trenches are ending. Non-invasive repairs like CIPP lining become the norm. The idea of jackhammering a floor to fix a leak will seem as barbaric as bloodletting.
Speed, safety, sustainability. Those seem to be the three pillars here.
However, there is always an economic caveat. We have to be realistic.
What's the catch?
Copper is a mined resource. It's expensive to extract and refine. So if global supply chains wobble, or if raw copper prices just skyrocket, the market will force a shift. We might see advanced composites, plastics that mimic metal properties taking a bigger slice. Money usually wins.
But for now, copper is holding its ground by innovating.
It is. It's betting that people will pay for health and longevity.
It really is an incredible evolution. We started this deep dive with that gritty image of the blowtorch and the wrench, and we've ended up with UV-cured epoxy liners and hydraulic robotics.
It's a complete reimagining of the trade. It's cleaner, it's faster, and honestly, it's better for the consumer.
So for you listening, whether you're planning a renovation or just dealing with a dripping faucet, this changes the questions you should be asking. Don't just ask the plumber, how much will it cost?
No. Ask, are you pressing or soldering? Ask, what technology are you using?
Ask, is there a way to line this pipe instead of tearing up my floor?
Absolutely. Knowledge is leverage. If you know that lining exists, you might save yourself $10,000 in floor repairs.
I want to leave you with a final thought to mull over today. We've talked about pipes that fight bacteria. We've talked about pipes that are installed with essentially robots. But where does this end?
That's the big question.
If our plumbing systems are becoming smart and antimicrobial, are we moving toward a future where our house doesn't just deliver water but actively purifies it? Are we looking at a future where the pipe itself diagnoses its own leaks?
Imagine that, sensors embedded right in the press fitting.
Right, a system that alerts your phone before the water hits the floor.
Huh.
Hey, moisture detected in the wall.
A nervous system for your house.
Yeah.
We're already seeing prototypes of leak detection valves that shut off the main automatically, integrating that into every joint. That would be the holy grail.
What happens when the pipes are smarter than the appliances attached to them? It's something to think about the next time you turn on the tap. Thanks for diving in with us.
See you next time.